have to find electric field at point A. This is minus Q charge and this is plus Q charge. So how can we solve, sir? You are taking 2 points, one is at axis and another is at... Dear students, welcome to Allen Overseas. Let's continue our special series. This series will cover 45 topics in 45 days. It will be really helpful for all the JEE Main aspirant. This is the distribution of topics in physics, chemistry and mathematics, and I'm going to cover physics part. So let's begin with the topic electric field due to dipole. This topic is from electrostatics and this topic is very important for JEE Main examination. So let's begin with the topic electric dipole, right? Why I am taking electric dipole? To understand electric field due to dipole, we should know basic about the electric dipole. You can see here, this is charge configuration, this is plus Q and this is minus Q, right? And separation between these two charges is 2L, right students? So this configuration we called electric dipole, okay? A system of two equal and opposite charges separated by very small distance is called electric dipole. Keep in your mind, we have to take this distance very small, right? Okay, you can say, sir, here electric dipole moment is written, okay? So what is electric dipole moment? Actually, electric dipole moment is the characteristic property of the dipole by which we can easily analyze electric properties by the dipole. Is that clear, students? So what is electric dipole moment? Electric dipole moment is simple. It's multiplication of Q and separation between the charges, 2L. Okay, this is electric dipole moment. It is represented by P. Sir, here you are using P vector. Sir, this is vector quantity. Yes, this is vector quantity. If I talk about the direction, so direction of electric dipole moment is always from minus Q to plus Q. Okay, so tail of this vector is at minus Q and head of this vector at the plus Q, right? And you can represent by P vector. If I talk about the unit, so unit is coulomb into meter, right? This is Q for coulomb and length meter. Okay, this is the unit. And keep in your mind, direction, it's vector quantity. So direction of electric dipole moment is minus Q to plus Q. Okay, now let's start our topic, that is electric field due to an electric dipole. Okay, so I'll take 3 cases. In first case, I'll find out electric field at the axis of the dipole, and in second case I will find electric field at the equatorial point, and in third case I will find at any general point. Okay, so here this is dipole and dipole moment is given, that is P vector, right? And separation between these two charges is 2L, right? And this is y axis, okay, and this is bisecting this length. Okay, so this length is L and this length from this point is L, right students? We have to find electric field at point A. Okay, now let's find. Due to plus Q charge, there are two charges. Due to plus Q charge, if you represent the direction of electric field, so direction is away from the plus Q charge. So this I am representing by E plus. Due to minus Q charge, you must know electric field is towards minus Q. This is I am representing E minus, right? You can say, sir, this is the direction. What about the value? What about the magnitude? You must know electric field due to a point charge is kq upon r square. R is the separation at which we have to find out the electric field, right? Okay, so now you can see here, if I write electric field at point A due to plus Q charge, that I am representing by E plus and I am writing only magnitude. Okay, so magnitude is kq divided by r square. Sir, what is r here? So you can see in this diagram, this is L, this is given r. Okay, from the center of the dipole is r. So this distance you can easily write r minus L. So this is r minus L. Similarly, from this point, the separation is this. You can see here, from this point to this point, r, this is L. So this is r plus L. Is that clear, everyone? Right? So due to plus Q charge, electric field kq upon r square, it's r minus L whole square, right? Similarly, you can easily find due to minus Q charge, only magnitude I am writing here. Okay, so I am writing like this, only magnitude. So it's kq divided by r plus L whole square. Okay. So this is the electric field due to individual charges. If I represent the direction of net electric field, so you can see here, magnitude of electric field due to plus q charge is more. Why? Because this distance is less. So net electric field will be in this direction, right? This is net electric field at point A in this direction. Okay. This is dominating. So net will be in this direction. So if I write net electric field here, so E at point A is E plus minus E minus. Is that clear, students? Only magnitude I am representing because we already represented the direction. Now see, it's KQ divided by R minus L whole square minus KQ divided by R plus L whole square. Right, students? You can take KQ common, right? And it's 1 upon R minus L whole square minus R plus L whole square. Let's take LCM. So KQ divided by LCM is R minus L whole square and it's R plus L whole square. Okay. And so here R plus L whole square minus R minus L whole square. Right, students? We have to solve this. So you can see here E at point A is KQ, right? And if you open this, so it will be R square plus L square plus 2RL. Similarly, this is R minus L whole square, so it's R square plus L square minus 2RL. Got it? Divided by, see, this is A minus B, A plus B, right? So we can write A square minus B square. So I'm writing R square minus L square and its whole square. Got it, everyone? So you can see here KQ R square plus L square plus 2RL. If you open this, then it will be minus R square minus L square plus 2RL. Okay, divided by R square minus L square whole square. Okay, students, right? You can see here this cancel, this cancel. Okay, so remaining term is KQ and this is 2RL, so it's 4RL divided by R square minus L square and whole square. Is that clear, students? Sir, is this the answer? No, right? You can write this is electric field, but we learn one thing related to the dipole. Separation between the charged particle is very less. So we have to use that property. So you can see here separation is 2L, right? So 2L is very less than R, right? Is that clear? So you can write R square minus L square nearly equal to R square. Is that clear? You can neglect this L square, right, students? So you can see here electric field at point A, right, is KQ and it's 4RL as it is divided by, this is R square we have to write. So this is R to the power 4. Got it? And we can cancel 3 times. So this is E at point A is KQ, it's into 4L divided by R cube, right? Sir, dipole moment is given. Can we write this formula in terms of dipole moment? Yes. Just see here. I am writing this like this, 2KQ, right? 2KQ and into 2L divided by R cube, right? You can say, sir, Q into 2L is our dipole moment, right? So P is Q into 2L. So you can replace this with P, right? So it's 2Kp divided by R cube, right, students? So this is the magnitude of electric field at the axis of dipole. You have to remember 2Kp upon R cube. Got it, students? Now you can see if we want to write electric field in vector form, in that case what we have to do. So let's understand this. So you can see here in vector form, we have to write electric field. Okay. So see here, this is our dipole. This is minus q charge and this is plus q charge, and we have to find at point A, right? This is point A, and separation from this is given, this is R, right? I think you must know direction of electric dipole moment is from negative q to positive q. This is P vector, right students? Okay. We can define in this direction one unit vector that I am representing by P cap. Okay, that P cap will represent only this direction. Okay, students. So if you represent electric field in terms of magnitude due to dipole at the axis, this is Kp upon R cube. Is that clear, everyone? And in vector form, if you want to write, so it's EA vector is equal to 2Kp divided by R cube. This is magnitude. We have to multiply with unit vector. So unit vector is P cap, right? Is that clear? And I think you know that magnitude multiplied by unit vector is your vector. So you can write EA vector is equal to 2Kp vector divided by R cube. So this is the formula in vector form to calculate electric field at the axis. This P vector is representing the direction of electric dipole moment. You have to keep in your mind, you have to put each and everything with sign if you are writing in vector form. So direction of electric field, right, in this case is always along the direction of electric dipole moment. So if electric dipole moment in this direction, so direction of electric field is also this. Is that clear? So you have to keep in your mind this formula and this magnitude formula. Okay. Now next case in which I will consider point is at equatorial line. Okay. At this equatorial point we have to find out electric dipole moment. So let's find. Process is same. Okay. Just see here. Electric dipole moment is given, that is P vector. This is minus q plus q, direction is minus q to plus q. Separation between them is 2L. Okay, and we have to find at this point, and this is R. Okay, students. So how can we find? First find electric field direction. So due to minus q charge, direction of electric field is towards the minus q charge. Okay, so this is the direction of electric field. This I am writing E. Okay, not E minus. I will tell you later. And due to plus q charge, direction of electric field is along the line joining and away. So this I am again writing E because magnitudes are same. Why? Because this distance, if you calculate this distance, see, this is perpendicular bisector, right? You can use Pythagoras theorem. So this distance is under root R square plus this length is L plus L square, right students? Similarly, this length is again same under root R square plus L square. If you want to find net electric field at A, so what you have to do, these are at any angle. Okay, we have to find this angle. Let's say this angle is theta, right? These two are equal. So this angle is also theta, right? Now see here. See, this angle is theta, then this angle is also theta. If this angle is theta, then this angle is also theta, right students? I am representing here everything, right, for better understanding. See, this is point A, and electric field due to plus charge is this, and electric field due to minus charge is this, and this angle is theta, right? If you take component of this in this direction, so component of this electric field is E cos theta, right, along this, and component of electric field in this perpendicular component is E sin theta. Right students? Similarly, if you take component of this electric field, so one component, this angle is theta, so this component is E sin theta, and this side component is E cos theta. Is that clear? You can see here, this component is equal and opposite, right, to this one, so they will cancel out. Okay, so net electric field if you calculate at point A in the equatorial case, in that case, net electric field at point A is 2 times E cos theta. Simple. Okay. Sir, what about E? E is same, KQ upon R square, right? So 2 times KQ upon R square. R is this, okay? This separation. So under root R square plus L square and whole square. And sir, what about cos theta? See, cos theta is base upon hypotenuse. So base is this L. So L and upon hypotenuse is this. So under root R square plus L square. Right, students? Okay. Now see. So electric field at point A, this is magnitude. 2kq into L divided by, this is R square plus L square, right? And this is R square plus L square to the power 1 by 2. Okay, base is same, so we have to add power. So you can see here, electric field at point A is 2kqL divided by R square plus L square to the power 3 by 2. Okay, is that clear? Now we have to take that assumption in which 2L is very less, right? 2L is the separation between minus Q and plus Q. So you can see here, EA is 2kq into L divided by R square plus L square to the power 3 by 2, right? And we know that 2L is very less than R. So we can write R square plus L square nearly equal to R square. Is that clear? So electric field at point A, okay, is 2kqL divided by, this is, we can write R square to the power 3 by 2. This to this 2 cancels. So EA is 2kq into L divided by R to the power 3, right? You can say, sir, we know electric dipole moment P is Q into 2L. So we can replace this Q into 2L. We can write like this, E at A, K Q into 2L divided by R cube. Right, students? Yes or no? After that, E at point A is Q into 2L is P. So Kp divided by R cube. This is the magnitude of electric field at the equatorial point of the dipole. Okay, Kp upon R cube, you have to remember this one. Okay, you can say, sir, what about direction? So just see, direction I am representing. You can see here, this is our dipole, right? Here is minus Q and here is plus Q, and separation between them is 2L, right? And this is the point at which we have to find electric field, right? So net electric field is coming in this direction, right? This electric field magnitude, if I talk, that is Kp upon R cube. Sir, what about direction? So you can see here, P vector is in this direction, right? P vector is in this direction. Opposite to P vector, unit vector is minus P cap. Is that clear? So if you want to write this in vector form, you can write like this. E at point A in vector form, magnitude Kp upon R cube and unit vector minus P cap. P into minus P, right? This is the magnitude and this is the unit vector. So this is vector. So you can write minus Kp vector divided by R cube. So this is the formula in vector form. Negative sign is representing electric field due to dipole at the equatorial point is opposite to the direction of electric dipole moment. That thing you have to keep in your mind. If you compare the magnitude, only magnitude, right? So in that case, this is the magnitude in the case of equatorial line and magnitude of electric field in the case of axis is 2 Kp upon R cube, right? So if we compare only magnitude, so electric field at the axis of dipole is 2 times, you can see 2 times of electric field at the equatorial point. Is that clear? So you have to keep in your mind these formula. Okay. Now the last case, which is at any general point. So how can we solve, sir? You are taking 2 points, one is at axis and another is at equatorial line. But if I take at any angle theta, in that case, what we have to do? Just see here. So this is the point A. This is general point at which we have to find electric field due to dipole. Okay, dipole moment is given. We can represent dipole by this arrow. Okay, this is representing the direction of electric dipole moment. Okay, this is theta, right? So what you have to do, this is vector quantity. So just take two components of this. One is along this line. Okay, that component I'm using p cos theta. Okay, and one is perpendicular to this line. This is p sin theta. Now you can see, sir, we learn this type of concept because for this dipole, this point act as a axis, right? This is point at the axis of dipole, and for this dipole, because this is perpendicular to this, act as a equatorial point. Okay, and you must know the formula I am writing here. Due to this one, okay, p cos theta, direction of electric field is in the direction of electric dipole moment. So direction of electric field is this. This I am using E parallel. Okay, name is E parallel because parallel to this direction, right? And due to this, direction of electric field is opposite to the electric dipole moment. Okay, so this is in this direction. So direction of electric field is like this. This I am using E perpendicular, right? So we can write easily E parallel is at the axis. It's 2 kp, not p. Electric dipole moment is p cos theta. Is that clear? So it's 2 kp cos theta divided by r cube. Is that clear? Similarly, for perpendicular component, it's kp upon r cube. P is now p sin theta. So kp sin theta upon r cube. And they both are perpendicular to each other. If you find net, so net somewhere here, okay? So this is the net in the general case, right? So if you calculate net electric field, I think you must know how can we add two vectors. How can we find magnitude of two vectors which are at 90-degree angle, right? What is the formula? Under root a square plus b square plus 2ab cos theta. Cos 90 is 0, so under root a square plus b square, right students? So it's E parallel square, right, plus E perpendicular square. So I am writing it's 2 kp cos theta divided by r cube square plus kp sin theta divided by r cube square, right? We have to solve this. So we can take, see, this is kp upon r cube square. So if you take out from the under root, it will be kp upon r cube, right? And remaining term is, see, 2 cos theta square. So 4 cos square theta, right? And it's plus sin square theta, right students? We can write this like this, kp upon r cube under root, this I am writing 3 cos square theta plus cos square theta plus sin square theta, right? Cos square theta plus sin square theta is 1. So you can write like this, E net is kp upon r cube under root 3 cos square theta plus 1. Okay, so this is the general formula to calculate electric field due to dipole. Is that clear, students? Sir, what about direction? See, for direction, this angle is theta. You can consider this angle, right, is phi, right? Is that clear? This angle is, let's say, phi. You can easily find tan phi. So tan phi is E perpendicular upon E parallel. Is that clear? So E perpendicular upon E parallel. What is the value of E perpendicular? Kp sin theta upon r cube. So kp sin theta upon r cube divided by parallel 2 kp cos theta upon r cube. So 2 kp cos theta upon r cube. This cancel, kp cancel. So tan phi is your sin upon cos. You can write like this, sin theta upon 2 cos theta. So tan phi is tan theta by 2. So phi is tan inverse tan theta by 2. Is that clear, students? So this is how you have to remember this also. Is that clear? So by this you can easily find out the direction. Got it, students? Yes or no? So I think you all are equipped with all these formula and you have to remember all these formulas, and definitely you can score very well in your JEE Main examination. Now, sir, what about application? Right? You can say. So let's solve one question based on this concept. So let's read the question. Question is, a dipole is placed at origin of coordinate system as shown in figure. Find the electric field at point P, 0, y. Okay, coordinates are given 0, y. At point P we have to find. You can say, sir, we observe same type of question, same type of concept. Yes, this is at any general point, right, students? So you can see here, this is 45 degree, this angle is given 45 degree, and we have to calculate at P point. So what you have to do, you can take two components. One is along this is P, dipole moment is given. So it's P cos 45, right? And perpendicular to this is P sin 45. Okay, is that clear, everyone? Now see, I'm solving like this. This is P cos 45. Cos 45 is 1 by root 2. So dipole moment is P by root 2. And we have to calculate at point P, right? Coordinates are 0, y. Okay, so this distance is y. Okay, and I think you know that this is the point at the equatorial line. So direction of electric field is like this, right? This is the direction of electric field. Okay, this I am giving name E1. So E1 you can write, magnitude is Kp upon r cube. So Kp, P is P by root 2 upon r cube is y cube. Sir, what about direction, right? This is x-axis, this is y-axis. Along y-axis unit vector is j cap, along x-axis unit vector is I cap. Opposite to x-axis minus I cap. So you should write minus I cap. Is that clear, right? For second part, you can see here your dipole is like this, right? Like this. This is P by root 2 and this is at y separation from this point. This separation is y. And this is at the axis. If I talk about the direction of electric field due to dipole at the axis is always in the direction of electric dipole moment. So electric dipole moment is in this direction. So electric field, this I am giving name E2. It is in this direction. Sir, what about magnitude? So magnitude you can write, with direction you can write E2 is, formula is 2 Kp, P is P by root 2. So 2 Kp by root 2 divided by r cube is y cube. And direction, this is along negative y-axis. So minus j cap. Is that clear, students? Minus j cap. Got it? If you want to write net electric field in vector form, so net electric field you can write at point P. This is Kp, right? Kp upon root 2 I am taking common. Kp upon root 2 and y cube. Kp upon root 2 y cube. And it's minus I cap minus 2j cap. So this is the answer in vector form. I think you all understood all the concept. Hope you all understood all the concepts related to electric field due to dipole. Don't forget to watch our complete series. The playlist link is available in the description box. Still, if you have any queries or suggestion, feel free to reach out to us. For more, stay tuned with us. Thank you so much.